I came here feeling like I knew lots of things about local first software, and it's been really humbling to see all of the talks and see the amazing things that everyone in this room is building. So thank you for having me while I also share some things that I've done. I want to start by reading this quote from Steve Jobs. He goes on and says some more things, but he says that, that everything around you that you call life was made up by people that were no smarter than you. The Ebola vaccine, all the amazing work with CouchDB, I genuinely think that all of us could build software like that and build systems like that and vaccines like that. Like, so much potential, I think, is trapped up in ad tech and different problems that I'm sure are very important and will make people a lot of money. But I really feel like, when you really understand this, we can make everything be malleable. We can change things. If you're sitting on a chair that's not very comfortable, someone designed that, and you might be able to design a better chair. So this is me. I've done a whole lot of things. I've also been doing local first long before that was a thing, or at least thinking about it. In 2011, I worked on Google Wave. Can I get a show of hands? Yeah. It's amazing. I ask that question a lot at talks, and I think this is the highest percentage of people that remember Wave, which is really exciting. So we did Google Wave. I went on and made something called Share.js and then ShareDB, which was my sort of way to feel better about myself after they shut it down. And then made a library called OT types, where we use operational transform to be able to do JSON editing. And I've now learned that these things are called sync engines, I guess, which I've been building for a long time. And I really wish that there were other people around me at the time while I was building them so that I could share with you all the amazing technologies and techniques. More recently, I've been working on a CRDT library called diamond types. I care a lot about performance. I made I don't know why that's cut off at the bottom. I made a CRDT library for text editing called Eggwalker. Some people might know me from some blog posts that I've written. I wrote a paper with Martin Kleppmann, who's here, and supported by Mike Tumum, who's also here somewhere. So thank you, everyone, for that. But we want to make text editing work really well. This is me as a kid. I've always thought since I was a kid that programming is magic. We can build software that can do literally anything that you can express. So if you can express an idea clearly in complete detail, then we can make the computer do it. It's like being able to be a wizard and just create life from nothing. And that's why I get really sad at the modern state of software, like I'm sure a lot of you here, that I have to make this choice between building local software or cloud software. I feel like I'm a beggar with cloud software, oh, please, cloud service provider, could you please store my data? Please don't shut down at an inopportune moment and delete all of my things. And I feel like we can do better than that. If we can do anything, we can make software. So we can build these amazing local first software stacks. But right now, I feel like all of these amazing tools people are doing, it's like we're going out into the desert, and then we've got to rebuild civilization from scratch in the desert to be able to make one piece of software. And then someone else is making a different piece of software in a different town, and there's no communication between the towns. I mean, that's what we're here for, but I want the data to be able to move around as well. This is what I want. I want an operating system where all of the hard bits happens inside the platform, inside the system. And all of the app developers, people that are running around trying to cure Ebola, can spend 3 weeks building an amazing application on top of a software stack, which we can trust, that works well, it's consistent, and lots of software developers can understand it without needing to read white papers and learn a million things. And if we can build something like this, then I think this is what's really going to enable local first software to take over the world, because it means that anyone can build the software that they actually want to do on the ground. While I've been here, a lot of people have asked me why we should do all of this. Why should we put local first software ideas into the operating system? And I've started to think about this, I want you to imagine an alternate universe in which the file system wasn't part of the operating system. So the operating system provides every application a hard disk, or maybe a partition on a hard drive. And we have a conference just like this. In 2025, it's the File System Conference. And lots of people gather in a room, file systems. And, and we share all the amazing ways that we're building file systems. And we encourage people to embed our file system into their application so that when your application is given an entire partition on the hard drive or an entire hard drive, that you can do good work with that. But I'm sitting here thinking, well, it's better if we can have the file system in the operating system, because then all of the programs can just talk to a file. And then 2 programs can talk to the same file. And then I can have one program called Apple Finder or Windows Explorer or whatever, and I can drag a file onto my USB key. And I can have another program that can open a JPEG file. and another program that can save a JPEG file. And all of these different programs can interoperate via talking to the file system. And that's what I think we need to do with local first software to be able to make it really work well. Part one, what is an operating system? Sometimes I think about this. As software developers, we often take for granted the operating system, or we take for granted Postgres. If I showed you, I thought about putting up a slide of like code from an operating system, and from a distance, we can't tell if it's an operating system or it's a React app or it's something else. Like, code is code, and if we can write software, we can edit all of this stuff. I'm sorry about it being cut off. I'm going to try and full screen again. Let's see if that helps. Hey. I think about this stack. Right at the bottom, we've got these sort of principles of what do we care about. And in the middle, we build a platform. So the platform is all of the services that the operating system provides to users and provides to applications. And then at the top, we have an ecosystem of applications that get to take advantage of all of that. If it was a country, it's sort of like this. Like, here we are in Germany, and in Germany, they have the principle of universal education, that everybody gets to go to school. And then the infrastructure is that we've built schools in lots of countries. And as a result, little Gerald up there gets to go to school. And his parents don't have to think about it. And if we didn't have these principles underneath, then, well, most parents just would have to make their own school to be able to send their kids to school. So lots of kids wouldn't get educated. And that's where I think we are with local first software right now. And the other thing is that standards are good. If we all go to the same schooling system, we all have an expectation of what we all know. We all can speak the same languages. We all learn to read and write. Because Unix is a standard, we can use computers that other people have, and that's really great. I love all of the amazing innovation happening in the platform space with local first software, but there's so many different ideas. And I really want to reward developers for understanding some common set of tools so that we can build amazing things and build an ecosystem that works. This is kind of how I think about that with Linux, but I'm going to move pretty quickly. The Unix philosophy, which underpins Linux, I still love. It is this idea that programs should do one thing, and they should do it well. Programs should be written to be able to work together, so you can have multiple programs that interact. And the last part of the Unix philosophy is that files and text are the universal interface. So I think 2 out of 3 is not bad. But when we look at like Ken Thompson and Dennis Ritchie, here they are working on Unix, and you might notice that there's no computer monitor here. Unix was invented and files were invented before computer monitors existed. And so when they said that text is the universal interface, the reason is because they were programming on a teletype machine where you would type into the computer and it would print out things on a typewriter. And that's what we're currently still using in our computers because we just haven't changed it yet. No one's changed how file systems work. I could spend an hour just telling you why I think files are terrible for local first software. They don't provide the primitives that we need to be able to make interoperable software that has the principles of local first software, where my files and my data can synchronize. Building something like Dropbox is actually quite technically difficult, and it's very limited in what it can do because files don't give us the abstractions that we need. So really, we have this problem, which is that we know the principles of local first software, and thanks to PVH and all the people that wrote that amazing paper, and we want to build apps. I think about local first apps as being creative apps. That's the thing I care the most about. I want to own my own data whenever I'm writing things and creating things from scratch. And we have this problem in the middle of what does the platform look like that's going to enable this stuff higher up. So I don't have all of the answers, but I want to make a modest proposal of something that I think might help. I feel like we've got this problem, that right now we've got sort of centralized software that isn't reactive and real time. And we want it to go into the top right-hand corner where we've got local first software and my data can just live on all my devices and synchronize and everything updates in real time. I think of it like this, that we kind of want to cross this river of complexity, and it's hard to get across. And when we have this problem, I sort of want these little stepping stones of places that we can go that are also useful, good software, and somewhere else where we can build useful, good software, and eventually we get to the other side of the river where we've got beautiful things. We've got local first applications. So in my mind, I think that what we want is something like this. We want some like owned reactive data, and I'm going to show you an example of what that looks like. And then from that, we can add decentralization by putting things in CRDTs. So I think it's time to show a demo. Everyone's demos have been working really well, which raises the stakes. So I built this over the last few days. This isn't really via Vim, but the idea is, maybe an operating system could look like this, and I can say hello in my text editor, and everything looks fine. But actually, what's happening is that this isn't really a file. This is actually an object that I can subscribe to. And as I type, we can see all of the edits showing up in real time. So any application can subscribe to an object, and we get the initial state. So here we are, it said hello. And then we get a series of changes. And if you apply all of the changes in order from a snapshot down, you can get the resulting state of exactly what this document looks like at any point in time after that point. And this means that I can do things like this. Like, let's open up Emacs. It's not real Emacs. It loaded too quickly. I'm going to open up my file, and now, as I type, everything updates in real time. This is how software should work. Thank you. So what's going on here is that we've got this kind of mutable object. And right now, there's no CRDTs involved. There's no magic. This is sort of tens of lines of code. Shout out to Dev, wherever you are. I wrote all of this in Solid.js. Hey. Which is great for this kind of work. So I want this sort of mutable object, and time's going down from the top. So first of all, an application like Emacs can get the object. I say, I want to get the object and subscribe to it. And then the object returns me a snapshot and a version of the document. And some other computer, it could be the same program, can send mutations. And as a mutation comes in, the object can take that mutation and broadcast back out the delta coming down. And as mutations happen, the object can broadcast the changes. And if someone just takes the snapshot and all of the deltas and applies them all, they should end up with the current state, like the correct state. I think this is a beautiful system. This is something, where is Mike? Mike is over there. Mike and I worked together a lot in the Braid group years ago, and we talked a lot about this, and I managed to refine these ideas there. So lots of great work's happening. A mutable object like this can be centrally owned, and you can put arbitrary logic inside. Maybe it's read-only, maybe you delay or you coalesce all the writes, or you have a complex authorization function. And this lets us do lots of cool stuff. So one of them is that even though our network's protocol is complicated, we can have an API that's just simply like for await the state. You know, just get me the state as the state updates. Really, really easy to attach to a Solid.js signal. It's really easy to attach to React hooks to do lots of things with. And we can get deltas and versions out of this, which is what you want. If I've got a text editor, I don't want to get the entire new copy of the document with every change, because I don't know where my cursor should go, and it might be really big, and I might care about what the changes themselves are. But with this protocol, we can have something where I can get differential updates, and it works well. So I'm going to show that working in a few more contexts. First of all, well, here's my mouse. So as I move my mouse around, this can just be something you can subscribe to, of course. I can make, let's say, I made a Snake game, and I got Claude to make this game, so I can play Snake, so that's fun. Don't applaud, I didn't make this. But what we can do is take objects inside the Snake game. So for example, I can take the score in Snake and say, I would like to see all of the updates to the score. And now, as I play Snake, I can see my score update, which is what I want. And that's just a variable in a program can then just be exposed out, and something that any program can subscribe to or edit if we want to cheat at Snake. This is an Xbox controller, which I brought from home. And of course, I would like to also be able to see this controller. And I want you to imagine that this controller is actually associated with a different physical computer. Because these objects work with a network protocol, it actually doesn't matter where the object lives. So I can move my controller around and subscribe to the state of this device. And then, of course, programs can take data in from something if they know the type of it. So I can take my Xbox controller, and I can attach it. Oops, if I can reach. I can attach my controller to the Snake game's inputs, and now I should be able to play Snake like this. So I think that's pretty cool. And just for context, this one API, we've got variables, we've got objects on the disk, we've got things in memory, we've got aspects of hardware, all of these different things. I think lots of the infrastructure systems that you're all building could be built on top of a primitive like this. So the other thing that I want is shared objects. So I do actually want local first software. I don't just want objects that are centrally owned and controlled. I want to have replicas of some piece of data stored in a CRDT, and I want to have those replicas on different machines. Now, the really cool thing about this is that we can provide the same API here as we did with these centrally owned objects. In fact, the applications don't even have to understand that they're using a CRDT if we do it like this. There's a few little changes, like the mutations will always be infallible, and they will be instant, so there's no asynchronous quality, but that's kind of great. And we're also a little bit more limited about our data types and our authentication code and stuff. So let me show you that. I'm just going to close all of this stuff out. So I made a CRDT. I write CRDTs, so I thought it would be fitting. I have a branch. I've got a CRDT object, which is this like blog post I'm writing. So hi there, this is my blog. I'm also going to open up a window showing the published version of my blog post. I don't want to publish keystrokes as I type because, I might make a typo. So if I do this and open up my little CRDT manager, I can push the draft branch to the published branch, because of course. By the way, I think one of the great crimes our software developers have done is that we discovered that Git and having branches and merging and diffs is a fantastic workflow, and then we hid it from everybody. Like we were too jealous. Thank you. So here, the text editors at the top don't even know that they're using a CRDT. And we can do merging and branching, just like, and perhaps in every application, which I think would be fabulous. But then, of course, I want to have a little Markdown renderer. So I would like to render, say, let's take my published version. I'm going to render it to Markdown. And then that's going to create this like rendered view. And I'm going to grab like a HTML viewer and then take the rendered HTML and show it. So now I should be able to say, hello, this is a heading, blah. Push to publish, so publish that, and suddenly my rendered blog post updates in real time. And again, it's a CRDT. This should all be network transparent. So what I want is to be able to say, have a server over there, which runs my blog, and have the server store a replica of my CRDT. And on my desktop machine, I can edit a draft of my blog. I can see it. When I'm happy with it, I hit publish. It merges into a branch. And over on my server, it just gets all of the changes on the CRDT. And all it's doing is watching the published branch, and when a change happens, it broadcasts out my new blog post. I think this is how we can build software. But notice that it requires lots of different programs to be interacting with our CRDTs and interacting with our local first data. And I think that's where I want to go. I love all these giant silos that everyone's built. I think that there's amazing platform work going on. But I really want to be able to have a software ecosystem in which all of those data silos, like I can build software that can interact with all of it. I think that's where we want to head. So I've got a few more minutes. I'm going to say a few more things just to give you a bit more context. I could talk about this for hours. Please bear with me. There's a question that we've got of do we want these to be two different kinds of things, or do we want one kind of thing? Do we want to say, hey, Alex, wherever you are, could we please update auto-merge to also be able to support objects that aren't CRDTs? And that might be the right approach. I don't know. Or we could have two separate kinds of things, and then developers have to learn that there's two kinds of things in the world. They've got some different properties, like an owned object is CA in the cap sense, and a shared object is AP, and some different use cases. So I think for these kind of owned objects that you'd want to store, like, say information about a hardware device, because I don't want to collaboratively edit my Xbox controller. But I might want to collaboratively edit the input to a game. But I think that the controller itself should be like owned here. It's got a single writer. And then if you wanted to collaboratively edit something, then you could use a CRDT and have this feed into that. The work of this kind of has come out of many years. As I said, I've been thinking about this for, since 2011 and when I worked on Wave. I think about systems like this that do real-time updates as this sort of series of stepping stones where we can add more functionality. So the very simplest systems, you have to poll. So I say, like, what's the news? Website? And then it says, here you go. And if I want to see the updates, I have to refresh the page. And I have no idea if I'm going to get any new updates or not, but I just have to check it periodically. And in that case, like, how often do I check? Like every second, every hour? I might miss updates. I might do a whole lot of extra work I don't need to do. Better than that is polling with notify functions. So I think that, say, like the file system API in Linux works like this, where I say, I care about this file, and please tell me when it changes. And the operating system just says, oh, hey, the file changed. And then I can go and read a new copy. But there's two problems with this. The first one is I don't get to see what changed. In what way did the file change? I have to diff it or something, and that's going to be lossy. And the second problem is that, and of course I'm getting a whole copy of the file, we also have the APA problem, which is that it could have changed twice, and I missed the intervening change, and I didn't notice it. So event streams, like I showed, I still don't have a good word for this, these kind of owned mutable objects. Again, if someone's got a good word, please come and see me in the break. Maybe we can make it a thing. if you take the second one and you add streams, so I can subscribe to something, and I get versions and updates with differential updates with some sort of known type, so we all know and we all agree how we can apply the changes, then I think you get something much better. You still have the aeroplane problem, like these things, like Martin still can't use one of these things while he's on the train to Cambridge, because it's an owned object. But it's really, really simple, and we don't have to think about CRDTs to use this stuff. And then finally, the last step, in some sense, is much more complicated, but it's where we put all our data in a CRDT, and then I can replicate my object in 2 different places, and the replicas can synchronize with one another, which is what we want for local first software. So, in summary, let's talk about building this middle layer. What goes here? I've suggested some things. I think we should have these kind of mutable objects with subscriptions. Also, independently, no one's been talking about it at the conference yet, and I really want to. Schema migrations are really boring, but really important problem here. What would a local first database, what would all the databases that people are making look like inside this layer? What else do we need to put in here? Please, if you've got thoughts, let me know. And then just finally, a couple Q&A from my side. Do we need to make an OS from scratch? I'm not entirely sure, but I think it's fun. So I bought a little, like a little microcontroller, like a little onboard. This isn't a Raspberry Pi, it's something else. And I've been trying to get Cell 4, which is a little operating system built on it, so I can actually do this in real hardware, which would be really cool. But we could do it in a browser or on top of Linux or something. But there's something I think nice about having a space that's an ecosystem where every program inside the ecosystem is going to be built on these principles. And if down the track we want to convince Linux that they should really put it in the Linux kernel, which I think is a fabulous idea, I think it might help us to actually have experimented a lot and figured out exactly the right way to build this stuff and had a lot of conversations first. So I think it would be fun. I have no idea how to fund this stuff. If you've got thoughts, please talk to me. And in closing, I just want to give you this quote from Alan Kay. He talked about projecting forward 30 years and asking ourselves, what would it be ridiculous to not have in 30 years? And then ask, well, can we just build that today? And I personally think that it would be ridiculous to not have an operating system like this in 30 years' time and still be having these conversations. So I think we should start building it. Thank you.